All right, guys, this is going to be a rather quick one compared to some of the other things that we've talked about today. This is our integration with Metaswitch's SAS server, which stands for the Service Assurance Server. And basically what that server is if you're not familiar, is it's a server that gets messages from every part of the Metaswitch system, and it'll display ladder diagrams of signaling like SIP and H248. We'll show you in the practical, that kind of thing. And it also gives you a lot of information about what the brains of the Metaswitch is thinking, why it's doing it, why it's allocating. You see insight into the number routing and all kinds of things like that. So what we've done is we've integrated that communication into the TMG so that you get a fuller picture when you're looking at that. And it's really been wonderful on my side in the lab to troubleshoot things. And a lot of the things I can quickly troubleshoot without even going into the SSH of the TMG, which isn't the case with pretty much any other server. I'm going to need to start on the SSH. So it's been incredibly useful for me. So we're going to talk about what is the SAS, which we've already begun. We're going to talk about the interoperability with the TMG, and then it's really rather quick to set it up, but we'll show you that as well. So a lot of this is a little bit redundant. We've talked about how in the H248 environment, our TMG 3200 doesn't really show the ladder diagrams very well because it doesn't have any awareness of the signaling. The only thing that it knows is it's being told to open this and then pin it to that. And it's just like it's being the most simple of switchboards. So it can't really display much. But once we bring in this service assurance server from Metaswitch, it kind of solves all that. And you've got one place that you can go in this environment and you can get information about what the TMG is doing. You can get information about what the CFS is doing and how they communicate together. So as Luke and I have mentioned previously, the SAS is a license feature on the TMG, and that license feature kind of opens up all the Metaswitch proprietary packages that we've put in. So technically, you don't have to have this license feature to work in a Metaswitch environment. You can set it up just as an agnostic H248 media gateway, but you really get advanced insight and advanced control. And a lot of the features like the announcements have been tailored specifically to work with Metaswitch. So if you're looking at our firmware versions, or if you have one already in your hands and you're wondering if it's supported, probably not, because this release started with 3.247, and we're just nearing now where it's going to be officially available for public. Luke might be able to talk about exact timing a little bit better, but it'll be this quarter, and it should be very, very short. So I mentioned before all those applications that we have running on our CentOS box, and one of them is called the TBUCT writer. Each one of those applications has different responsibilities, and they make our system work as flawlessly as it does. So this is the main one you're going to want to drill down into if you have any issues with the SAS configuration. But in all honesty, once you set it up, it kind of just works. Yeah, go ahead.
Sorry, can you please just check? I think Conrad is having difficulty logging in.
Oh, sorry, it's my job. I'm used to letting Joshua do that.
It's fine, thanks.
They should be in now.
All right, great. Looks like Conrad's in there.
Yep, they're in. Good.
So this application, if you're not using SAS and you're in another H248, you can pretty much just shut it down because it doesn't have much to do in an H248 environment, which is one of the major advantages of us recruiting this application to handle that SAS communication. As I mentioned, it's just not utilized in a normal Mageco or H248 environment, but it's super important here. So we're going to take a look, and there's a couple ways to find the apps on the GUI. The easiest way is probably directly from the status page. If you go into hosts, you're going to see the serial numbers of your control hosts. That's the CentOS box, to clarify. And you're going to see all the apps that are listed there. And you can see I've got a little arrow next to that UCT writer. So we've talked a little bit about what different apps do. Like there's the stream server. Obviously that handles the streaming of like the audio files and things like that. Luke mentioned the syslog being very important because it compiles errors from all the other applications. Gateway is what's handling the actual H248 communication back and forth between the MGC and the MG. And then we've got this UCT writer. So when you see this status, you can drill down into it and it'll drop you in the status page like that. And you can switch over to the configuration in the same layout that I've mentioned multiple times. Or if you look on your left-hand side, you've also got hosts and then applications nested under it. So once you go in there, it's really as simple as going into that. And here you see some of the configurations I've already talked about like increasing the log size, which is what we have here, that maximum file size and that maximum compressed directory size. And then right below it, you just have a square that says Metaswitch SAS, and it's as simple as that. So if you want to use the SAS server, which I would say in every Metaswitch environment, you should, you check the box, you need an IP address and you need a port. And that's it. The configuration is simple and it just takes a couple seconds, and we're going to jump in there and do it in a moment. So make sure you do drop down that application parameters. It's a little bit hidden on first insight. You can see how, if I can get my pen here, you can see how this is kind of in a box. And in our web GUI, that means that it's usually hidden by default. So you'll click this application parameters, and then you'll see this Metaswitch SAS that you can drop down again, go into. And like I mentioned, there's just 3 things you need to set up. It's very simple. All these are going to be the same in every single application, these controls right here, because they're just about the logs of the application. If you do get into some SAS troubleshooting, you might want to increase those, but generally in the UCT writer, it's not going to be needed at all. The only reason you're going to go in here, I think, will be to set up these 3 settings. Once the communication is up, the SAS server and the TMG are going to go through a rather quick negotiation. We'll watch it live, but it takes less than a minute generally. And you'll see in our status page, once you have that checkbox enabled, this SAS icon will appear. And there you get the connection status to make sure it's up. These trails right here are how the SAS keeps track of a call leg. So if on a live system, this is obviously a screenshot from my lab where there was no traffic at the time, but in a live system, you'll see that counting up based on the throughput.
And what is a trail exactly?
It's a call leg associated to one of our ephemeral or fixed termination.
Yeah, but this trail ID also goes in all the signaling messages of the MGC.
Yes.
Right? The trail ID is all the signaling for that particular call.
Yes. And so it's per leg, I think, not per call, right?
Per leg? Okay.
I think so. We'll double check that when I take a look at one of my calls, but I believe if you have 2 legs going through, you'll get a trail.
2 trails. Okay.
Yep. And here in the log, you'll see every time we send a SAS message as well. But the main thing I wanted to show you, this was the part that I was trying to show you yesterday, and I forgot that we hadn't set up SAS yet. So that'll just be totally vacant if you don't have the SAS enabled, as we saw. But once you enable the SAS, you'll see that status up or down based on the IP connectivity, the address that you have it pointed at. And the port number that you're communicating on. Metaswitch version to support the Tmedia. I can pull up mine, right?
I saw the question. Okay, so this is it's not an easy answer, right? Because we've been installing devices with Metaswitch probably the first one maybe 8 or 10 years ago. So we've installed others over time. So it's working today. Now we are doing additional proprietary messages. So this is a new TelcoBridges Tmedia version that we need to have on the on our products to support these new messages. Also for the SAS integration, we need to have this new version that Joshua was telling you about. On the MGC side, we need to verify. I know we made a change for IUA. So if you need to use IUA, there was a change made on the MGC. However, I don't know if there was any changes done to the SAS server. I think it was only on our side. So I think it would work probably with any MGC version. But we can verify if there's other cases that are limited with the older Metaswitch version.
And I put in chat the MetaView version, the CFS version that we're doing all of our interop tests on. And remember, it functioning with all the proprietary packages are a little bit different. Was there anything they made changes on besides the IUA?
Yeah, that's what
No,
I'm
right?
thinking, and I don't think so. Right, I think we adapted our software to make sure it works with all the messages, but I don't think there was any other changes.
That's my memory as well. So I think as long as you have the newest TMG, the only question is going to be the IUA, if that will work, which is when you need that ISDN signaling going over IP. So one more thing to just be aware of is, since all these encoded messages come through, the SAS server needs a way to decode these messages into human readable events. And how it does that is with a YAML file. And so every TMG release, we're going to issue a new YAML file, even if there's been no changes to the SAS whatsoever. So doesn't necessarily mean every time you update, you need to update the YAML file, but that would be best practice. So even when there are no changes, we'll have a new one. And the YAML file is what helps the SAS server translate the TMG's messages into a human readable format. So your SAS server is a rather simple GUI, and I'm going to pull one up here so that you guys can see it. And if you need to update that YAML file, you go into admin resources, and you can see here there's only like 5 or 6 buttons. So there's not much of a chance to get lost in this. In the MetaView Explorer and the CFS, it's very easy to get lost. In the SAS, not so much. And to take a look at what I mean here about these ladder diagrams. So you can see that inside of a call, you've got 5 different tabs in each one of these calls. And the call flow is probably the most useful to know what happened right away. Here we've got the SIP message going through, which, remember, we're an H248 gateway, so that has nothing to do with the TMG, but the H248 messages do. So one thing I want to point out here is how in the SIP call, there's just one red arrow, but on the H248 exchanges, there's 2 green arrows. You can see the 2 lines here. And what that 2 lines means is both the CFS and the TMG have reported this message to the SAS server. So at a quick glance, you can see that everything's connected and everything's synchronized because of that. You can see that every time an H248 message is sent in this call, the CFS says it sent it, and the TMG says I received it, and vice versa as well. The detailed timeline is where you get into some of your really more severe troubleshooting. And here we have some trail IDs, Luke. So I think I'm confirmed on the 2 legs. Okay. So in the detailed timeline, one thing to keep in mind is this event summary gives you how detailed you're looking at, engineering level events being the lowest one. If you see some issue, like maybe you sent the TMG a codec that's not supported, or you have the TMG in your CFS a little bit misconfigured about codecs, and the TMG needs to reject the request to be the media mixer, you'll see that there, and you'll see the message why. You'll oftentimes, or every time, excuse me, you'll see an H248 error, and then oftentimes you'll see the interpretation by the CFS or by the TMG of what or why it happened. When you drop down this one right here, you're actually selecting which device's messages you're looking at. So here where it says TMG 25248, you might be beginning to recognize that serial number. That's the serial number of my unit in the lab. So you can tell that every one of these messages, what RTP port we're using, those ephemeral connections that we were talking about, and then what codec gets selected here. All of that information is being sent to the SAS server directly by the TMG. A lot of the information, especially H248 messages, will be redundant because both the CFS and the TMG will send them. But some of the things, like when this ephemeral termination is created, it's just going to be coming from the TMG because the CFS doesn't know for sure until we've told it that. And so that's everything that I wanted to show you right off the bat. Now I want to pull up this. Actually, I will pull up the TMG first. And we'll go ahead and configure that. Let me change my color scheme here. And then zoom in. So as I mentioned, 3247 is the newest. I'm on 3250 right here. And I don't have a SAS tab at all on my status. So the reason that is because it's not enabled. So I'm going to go down here under hosts, and then nested into that is applications. And here we can see I've got one of each instead of two of each because I'm not looking at status. So this is control that will apply to both my primary and secondary. If I was looking at status, I would see their individual statuses in my 1+1 system. And I'm going to drill down into my unique call trace writer, or the TBUCT writer. As I mentioned, the stuff is hidden right off the bat. So I need to click this application parameters and enable that. And I don't remember my IP, so I'm going to check it from my power. So 192.168.100.243. And 6761 is my port. So I'm going to bring that online, and I still see no SAS here, and that's because the configuration change I just made has not yet been activated. So want to go in here, and September training is the one we've been using all week, or week and a half, I suppose. Activate that. Everybody gives me green success. And there we go. My SAS status is right there. And as we can see, that was very, very quick coming right up. It's just a hello message that comes back from the SAS rather quick. So I don't usually even see this down or training when it comes up. And now I want to pull you into my CLI of this same unit, the system under test here. So to remind you guys to see our applications, it's TBX CLI tools remote, but if you just type in TBX tab, the system will finish it for you. So that's the easy thing to remember, TBX being TelcoBridges control. And so I'm jumping in there. You can see actually, because I was doing some failover tests today, you can see my secondary server has the UCT writer active on it because it's green there. So I'm going to go in there and see that same communication. And I should be set up to put a call through here, and we should see some information. So I've got a call that's successfully connected and going through. I'm basically just using two soft phones. You can see here, I've got RTP going through them. And we've got some residual error message that just need to be cleaned up by engineering. You can see these are not implemented. There's nothing here that's causing any problems. Those are just because I'm still on a release candidate build. So what I want to do now is I want to pull up my actual SAS server. And if I look for this call right now, just so you guys are aware, it's not going to be there. The SAS server takes about 15 seconds after a call has been completed to fully register everything. So it gathers all the information and saves it. So now I'm going to end that call that I was on, and I'm going to wait about 15-30 seconds and research. 201 is what all my subscribers begin with. And since it's not a very busy system, I'm just doing it in the last 5 minutes. While we're waiting for that to come in, I'm going to go into admin, and I can see my resources like I talked about. And here is my current YAML file. You can see I'm a version off. I should be on 3250.
So the SAS server is something that is provided by Metaswitch, and we have it installed on a separate VMware machine in our lab. So it runs independently from the TelcoBridges software. So of course you need to have the Metaswitch SAS license to run this. Right?
Yep. This is part of our whole cluster of, what is it, 5 or 6 Metaswitch servers to make everything work. And the SAS server is one of them. And as you can see, and I just mentioned, it's detecting that my YAML file is outdated, but it's not going to cause any issues here. Summary really doesn't give you very much information. The user experience is nice because you can just see, was it a normal call? In our case, that it was. And then the detailed timeline and the call flow are where things really get interesting. So I'm going to hide the SIP here and just take a look at the H248. And here you can see every message going back and forth between our gateway, the TMG, and the Metasphere. You can see that that serial number is different because, as I mentioned, I'm on my secondary because I was testing failover today. And here you can see those specific ephemeral ports being called out. And I didn't send anything over the PSTN, so there's no fixed ports to look at, but you will see the error messages and the complaints here. We had a question earlier in the week about what happens if I misconfigure one of those. SAS is going to tell you right away too, even if you're not in the gateway debugging. The SAS in our detailed timeline is going to say there was no such termination. The media gateway can't do it. So I'm going to say in high level of events, real quick here, we see that in my scenario, the TMG SUT 3200, that's what I have it named in my SAS server, is providing ringback, and it's playing that tone on leg 20. Here we see them get deleted and torn down. We actually see full H248 messages here. There they are. And we get this full H248 message of exactly what's being sent. And I love this button here, which is jump to call flow. It's going to take you right to that packet if you're troubleshooting something. And as you can see, you can show every protocol all at once. We just don't really care about the SIP from our point of view. And the reason why these two legs are different is because my RTP and my signaling is coming from different points. But you can see they're both the same subscriber here. You can export this and send it to when you're making a request to Metaswitch support. If you're talking to me, you can send me one as well. Not all of our engineers here at TelcoBridges are used to using the SAS server, but I certainly have been. So if you and I are going back and forth, feel free to send them to me, and you can always just import them. So when you send me a file, I can go in here and import something and then see what was on your system exactly.
It's actually once the system is installed, the SAS server installed, it's pretty easy to get the file in, and you get all the information there, and you can drill down any message. So it's really helps to troubleshoot.
Absolutely. I'm quite enamored by this tool. I've fallen in love with it quite a bit. So as I mentioned before here, I've got all systems. Now I'm just looking at what the CFS is saying to the SAS server. If I think my problem's isolated there, but maybe I know for sure that my problem is isolated to the TMG. And so I can also switch that right there. And there's all my information. We can see here that RTP port 20 had an error, and then it gets modified, and then everything is happy after that modification. And the call lasted about 40 seconds after that.
Yeah, we can see they're in the same context, right? Like context 11 has C equal 11, right? That's the context. So you can see port 20 is in context 11, and below we saw 19 in the same context, right?
Yep, from context 11. 19, 20 both get put in there. So the context stays the same for the whole call, and the trail ID changes per leg.
There's one thing we didn't talk about. Look at the two above. You have the subtract. And at the end of a call, there's some information about what happened with the RTP in that particular call. Okay, so we can see here statistics NT/duration. So that was a duration, I'm guessing in millisecond. right? So that should be
56 seconds.
Yeah,
Yep, that's about how long my call
about
was.
long. RTP/PS packet sent. So these are G711 MULA. I think I saw in your I saw
I believe
PCMU.
so. PCMU was the selected one, I
Yeah,
believe.
there codec equal PCMU. Okay, so there was 2,838 PCMU RTP packets sent and 2,826 received. PL is packet loss, so there was no packet loss, no jitter, and of course it's a lab setup, so the connections are very short. RTP delay, that should be 24 milliseconds, so that's the round trip delay of that particular connection. And then CPL, don't remember CPL. IP fax, that's if you have sent a fax, you will see how many pages were transmitted. Remote packet sent. So you see RPS, Metaswitch, RTP. So this is an example of one of the proprietary message we implemented. So we will send what the other side has sent. So the other side has sent 2,826 packets, and we have received 2,826 packets. So we know that there was no packet loss in that connection. Remote packet received, remote packet loss, remote jitter, and remote delay. So we see we can have, and these information are gathered with RTCP, right? So probably when we take the trace later on, the media trace, we'll be able to see the RTCP messages being sent. So these are, the informations are assembled and put in those end of communication message, and then this can be processed by the servers to get the data on the quality of the connection. You talked about the YAML file here in this system, and on our system, I think it's going to be in each version that we upgrade, right? The YAML file will be included.
Yep.
Okay, so that's fine.
And the reality is, if we don't make changes, nothing will be affected if you don't update the new one. But the best practice should be update to the new one, because you don't know if we've made changes.
And I think we can find this file on our unit as well, right? It exists somewhere.
I think it's put on there when we install the new package. I could do a locate and try to find it. I usually grab it from here when I need it.
You grab it from where?
I grab it from the SAS.
Ah, okay.
But from what Tomas told me, and my memory is that it is put somewhere on our system as soon as the package is installed. So here's what it looks like. Not all that much information. It's doing the same kind of thing as a MIB file, essentially, right? It correlates specific short terms into longer things that can be used in the reading. Oh, we have more YAML files than I expected.
Very good. Yeah. Okay. So I think was there something else on this topic? Yeah.
I don't have the schedule up. Let me open it quickly. Oh, services. By that, do you mean SNMP and
Yep. So
like
it says everything was covered with SAS, right?
Okay. Yes, I believe so.
Okay.
You guys saw me set it up from scratch. it's three things. You enable IP import and you're done. And then the rest of the communication's handled. So it's really very simple, and I've never had to troubleshoot connectivity between the two unless it was just IP related. They seem to talk to each other very easily and very consistently. I've never seen any disrupts that wasn't related to my own VLANs or switching.
Yeah, well, that's the thing, right? We need to make sure we can reach it from the,
That's it. And one more thing to be clear, and correct me if I'm wrong, Luke, but this is all coming from the CentOS box, right? UCT writer is directly
Yes.
communicating from the CentOS interface. So
correct.
you want to make sure your management port can hit the SAS server.
Yes, let's show something else for SAS in hardware units. Yeah, click on yeah, this unit, okay. And then licensed features. And search for SAS in there. Yeah, so you need to have this particular license enabled for the SAS to come up. Can you see the other things here in these licenses? These are always included, like IUA is always there. Max trunk, that these are maximum number of T1s and E1s. So most of the time it's set to the maximum of the device, but there's some, in some scenarios we can have less than the maximum that the hardware can support.
The ones that are
then-
hardware ready for upgrades is the idea behind that, right?
Correct. Hardware ready. Yep. That's right. So the hardware ready means that all the hardware is there, but the license is less than the maximum and can be increased later. There's one other here was the MTP2 link. MTP2 links. Yeah, so number of MTP2 links is 16 on this box. So it can go up to 64 on those devices. And like I said, most of the other parameters are always set to the maximum on the system. So that's fine. Okay, very good. So let's, and
The only other,
else, yeah.
Yeah, the only other thing here is AMR. Like you said, we're not indemnified. And so if you have the right to use it, you guys can request the AMR license from us.
Correct. Here we're testing with AMR, so that's why the license is there. But
right.
Yep, correct. And this device doesn't have full VoIP, voice over IP chips on there, so that's why you see only a 408.
I don't think I've ran into an issue with that yet.
Well, if you use G711, you're probably good. Yeah, exactly, for 1600 channels here. So
yeah,
that's why you don't see it so much.
Yeah, and all my heavy load tests were all G7. So.
And you have only like 2 DS3s worth configured on the system. Right?
Correct. My third one's waiting.
Okay, very good.
All right, hand it back to you for services.
Yes, sir. Right. Here. So services, you may have seen it on the navigation bar on the left side. It helps you to configure some global services of the system, including SNMP and the web interface configuration. All right, so as also the date and time, SNMP, SSH, just a few things here we can do. So you saw just below where Joshua was, hosts and applications there where you can set the SAS client. Here we have the services. And when you click on services, you have all these menus here that appear. The first one is date time, which sets an NTP server for the system, which is the preferred synchronization scheme. Okay? And this synchronizes the host data and time. So that when something happens, like the SAS client has a new event, when there's a message that is sent, a trace that is captured, you make sure that it's the right time, and it's easier when you correlate different types of traces and logs. They need to be at the right time. It does not affect the TDM connection. TDM connection has a different synchronization scheme. Okay? This is only for the internal server, the database, and these things here.
And they come configured to CentOS's NTP servers by default, right?
Yes. So yes, correct. So we will. Yep, absolutely. DNS here. When you initially configure the system, you will do a TB change IP. This will give you the initial IP. It will ask you if you want to add DNS servers. It's the good idea to put the DNS server there so that when you update the system, it can resolve the names, right? So normally we want to have at least a DNS. If you don't do it on the TB change IP command line, we can do it here on the web interface. HTTP, you can choose which port you want to connect on the web interface we've been seeing from the start here. ICMP is only the type of service. So you see, you can have a type of service on every elements in the system. Not only these ones, but also RTP communication and H248 and other information. You can set a type of service to have differentiated services. SNMP, so we'll spend a bit of time on that to show how we configure SNMP and what is supported there. And SSH, well, you saw when we connect to the device, there's a default port for SSH. One of the way to protect a bit more these ports is to change the default port, which is usually 22, and you can change that and change and limit the IP interfaces that can connect to the system. So let's show this. The date and time scheme here, what you have is your time setting. You have two choices, right? Either you do a manual setting or you do NTP. So of course we prefer NTP because the time is always kept up to date. And then you need to choose your time zone here so that you have the time here. You can also use, I think you have the option for GMT as well in this list. If you look at down here, this will be your NTP server. So the default is to have those CentOS NTP servers. Depending on where you install the system, it will reach a different CentOS server here to get the timing, but you can definitely remove some of them and put your own time servers here in the system. You can also change here to a manual date, but then you see that you need to put a date here and do an apply. So you'll never be perfectly precise on the last second, right? And then you can drift over time. So of course, we prefer to have the NTP setting. But that's as simple as that. Just remember to activate the configuration for this. If you go on DNS here, like I said, you can do it with the TB change IP command. We have it here, TB change IP. So these are taken from this command that you have done and from the server. But here you can go and override this. So you can click here, manage by web. So the web will then override the DNS settings on the box from this configuration here. You can put here a list of name servers here and domains here. So here we put 888, but it should be a domain down here. Okay, so normally we use a DNS server that is inside your network or at your service provider. But I see a lot of users, they put just the Google domains here, and we encounter sometimes that they don't respond. So this can cause delays when you try to access these DNS servers. However, we use this almost only for when we do an update of the CentOS. We have every now and then we upgrade the CentOS packages, and you can update all of your systems to our repository. So we have all these files stored that are accessible from external. So if you do an update, you will have access to this, access to these files, and it will use these domain name server to resolve the TelcoBridges name. For the rest, normally on H248 system, these are not used. The third tab I should show is here, the HTTP one. So you click on HTTP here, and you can edit the default service or create a new one. All right, so the default is HTTP on a 12358 port. You saw that the initial connection is on 12358, but this you can change. If you want to use HTTPS instead, you can just create a new interface. You click here, use HTTPS, and then you can put a port. If you put 443, it's going to be the default HTTPS port, and then you can just put the IP address in the web portal. Or you can use any other ports here for more security. Then you can choose which interfaces are allowed to connect to the web interface. Okay, so by default, it is set to any. I think this is still set to any. Then if you want to be reachable only by the management ports, you can just click this here, or you can choose which interfaces could access the web portal. So you just need to be a bit careful here, because once you activate this configuration, you won't be able to access the web portal from any interface, only from the ones you have selected here in this list. I skipped here these two. I'm going to come back to SNMP in a second. SSH here, again, default is a port 22. So if you want to connect SFTP, SSH to the device, then you connect with port 22. If you want to change this port, you can select Manage by Web here, change the default port that you're using, and then you can also choose which ports can access the web interface. So again, be careful not to lock you out from the SSH interface. I come back here to SNMP section. So the SNMP we have supports the get and get next. Okay, so request. So you cannot configure the system. So we don't support the set option for SNMP. So you can get the information and you can have traps. So traps will be messages that will be sent from the media gateway out to the SNMP server to express a change in something. So for example, a void port that goes down will generate a SNMP trap and will be sent to the server. This can be displayed in the SNMP server saying that one of the void port has gone down. We have here in the SNMP section, we can configure some information. So the first information we have here is the port that will be used for communication. So this is 161 is the default SNMP port. So you can do a get or a get next on this port and the system will answer. You can add information here. This is a free-form text that you have here, and you can put information about the system here. And when you do a get, SNMP get on the, I think it's the system ID information, you will get all of this and you can know what device you are currently accessing. You have here some advanced parameters. I showed them because the default polling delay to generate trap is 1 minute. So that means the TMG itself will every 1 minute poll the devices, see if there was any change and send that out to the SNMP server. However, we have done some tests recently and it works very well with a 10 seconds polling time, which gives us a better response time on the events that occur on the system. So if a T1 goes down, 1 minute may be just a bit long here. So we want to get informed as soon as possible. So you can change this value to 10 seconds, and that works fine. The element down here is what type of SNMP you're going to use. So we support 3 modes, V1, V2, and V3. These two have a community name. So when you do a get or get next request, you will have these names inside. So these are the default names that we have. So you probably want to change this to make it just slightly more secure here. And if you want even more security, you can create a SNMPv3 user. But of course, your SNMP server must support this. So you have in here in the SNMPv3, you have passwords you can put, and you can configure a trap destination. So I will show you the SNMPv3 user. So you can create multiple users in the system. And then you have this. I don't know why we have this, because we don't support to set the SNMP. Then you have security levels here that you can choose: authentication and privacy. All right, so you can choose what type of security you want, and then you can put what type of authentication and privacy protocol you want to put, and the passwords and privacy information. All right, so you can configure all of this for more security on the SNMP. Then you have the SNMP traps. So this is where the information will be sent. So you can put the destination server, SNMP server IP. The port for traps, the default port is 162. So this is a well-known port for SNMP traps. However, this can be changed, of course. Here, there's special things about SNMPs. You can choose from which interface you want to send the SNMP. So maybe this was configured on a separate VLAN, separate network. So we can force the SNMP traps going to a specific interface. For the traps, also, we need to specify the SNMP version. If it's V2, we only have to put the community here. If it is V3, then we need to do like we did here, and you need to put all the passwords and the privacy phrase that we need to use here. Okay, so if you change to V3, you will see it appear. So the SNMP works with management information databases here, and it has different ones that are supported. So for example, we support the RTP1, the STM1, or OC3, DS3, T1, right? So if there's some errors that are detected, or if you want to get information about these interfaces, you can just do a query, a get, SNMP get, and you'll get the information. However, some of them were not supported. So we had information that were not in standard specifications. Like, for example, the M2UA did not exist in those configurations. So we created our own here, the TBMIB. These are, this is just a file which describes all the information that we can get from the system. And these are installed on the units. They need also to be installed on the SNMP server, so it knows how to decode the information that comes in from those messages. Okay, so if you look at the TelcoBridges MIB, what we have, we can get the temperature of the device. So we have multiple temperature sensors on the unit, so you can see that. Power supply status. So you can see if one of the two power supply is down. You can see the speed of the fan here if it's working normally. CPU usage. There's 2 CPU usage we can get. One is of the adapter. So that's the hardware unit or the telecom portion of the system. And as you've seen before, there's 2 CPUs, and these will be used when we do a new call. Right? So you could see if there's more calls per second in the system, the CPU usage will go up on these devices, and you can monitor this to make sure that there's 2 CPUs, right? You can monitor that the 2 CPUs are running normally in the system. We also have information about signaling. So in our case, we would use MTP2, M2UA, and H248. So there's information you can get about the signaling interfaces, like how many packets were received and all these things, if it's up or down. So you can get this. This one we won't use in MGC mode. This one, not super useful. High availability here. So when we run, as we have the system in the lab here, two devices, if one of them goes down, if there's an application that crashes, you can get the information here on the SNMP server about this. The clocking, so that's the synchronization on the TDM side. So if the synchronization goes down, you will be reported here as well. Line service usage, that's interesting. Also, it tells you how many time slots are being used right now on your system. All right, so you can have a global view of the number of time slots, because in a media gateway controller environment, you can get a lot of information from the media gateway controller, see how many streams you have configured and running and active. But on the device, it's a bit more difficult, right? So this is one of the place where you can see that. And these are example of traps. So if one of the power supply goes down, if we lose clock synchronization, if the MGC state drops, we can get some information here on the traps.